the pressure we applied on this. Due to the smaller size of particle of stationary phase, the packing will be tight. Due to the tight packing, flow rate of mobile phase will be reduced. So we increase the flow rate and increase the separation of compound, and efficiency we have to apply a pressure. So this is the generally things about the high pressure liquid chromatography. Now the definition of HPLC is commonly known as HPLC, and again this is an analytical technique used to separate, identify or quantify each component in a mixture. Now the mixture is separated using the basic principle of column chromatography and then identify and quantify by spectrography. Now the principle behind this HPLC is defined by the Van Demeter equation. Now for HPLC, the equation will be HETP is equal to A plus Cu. A is a eddy diffusion and C stand for mass transfer rate, and mu is the flow rate of the mobile phase which is used in the HPLC. So the basic principle of this HPLC is based on the Van Demeter equation. Now in HPLC we use mobile phase and stationary phase and column. So the commonly solvent is used like methanol, water, acetonitrile. We have added to the solvent acidifier, basifier and buffer solution are used for better separation. Means we added in the mobile phase because we use acidifier, basifier, buffer solution for better separation, because it will neutralize the ionized analyte or ionized compound present in our column, so separation will be better. So it's all about mobile phase. Now we come on stationary phase. So the stationary phase particle range is I have already discussed during the introduction part, but the stationary in phase the particle size ranges up to 3.5 to 10 micrometer. So we use two type of stationary phase. We use normal phase and revert phase. Normal phase in generally silica gel is used. Now in revert phase ODS silica gel is used. ODS means octadecyl. It is the acyclic hydrocarbon which contain C18 carbon, means C18 carbon atom. So now the third one is column. There is two types of column are used. Generally two, one is normal phase column and second is reverse phase column. Now we use normal phase column which contains silica gel only. We have already discussed in normal phase and revert phase in silica phase part. Now in revert phase column which we used ODS which contain ODS C8 matlab means 8 carbon atoms, octadecyl. We use revert phase ODS is used. Column is generally made up of stainless steel and internal diameter of column is 4 to 5 millimeter. Okay, now normal phase, the silica gel is a silicon group is present and responsible for polar nature. Silica gel is we used in normal phase and it is for polar nature. वो polar nature के लिए responsible होता है. Now silicon group is present in three form. First one is free silicon and vicinal free silicon and vicinal silicon and geminal silicon. Now in free silicon only one silica gel in present and bond with OH. Now vicinal now in vicinal there is a bond between two OH group which is side by side bond. Now in geminal on a silicon two hydrocarbon is attached. Okay, if if two OH group in attach in one silicon, we call it as geminal silicon. Now in revert phase HPLC, we also we know that ODS silica gel is used. Means there are two type of C18 and C8 carbon is used, mainly based on the affinity which one is preferred. Okay. Now the revert phase HPLC silica gel will be, this is normally a silica gel, but we convert it into non-polar by heating of silica gel in the presence of dilute acid. Now we will heat the silica gel for 24 to 48 hours, and after that silica is treated with organochlorosilane. Now then it's converted into a non-polar. Basically silica gel is responsible for polar nature, but when we use revert phase HPLC, now the ODS silica gel is used. So mainly the silica gel is converted into a ODS silica gel by treating all these chemical. So this is converted into a non-polar nature, because silica gel is responsible for polar nature and ODS is responsible for non-polar nature. Now the silica gel in revert phase, silica gel is mainly treated with HCl, then it's attached with the oxalane group, then it converted into the ODS by heating and treated with organochlorosilane. Okay, so it gives us C18 ODS, means 18 carbon atom. Now there is a type of HPLC, mainly based on modes of chromatography. Second, B, based on principle of separation, and C, based on elution technique, based on the scale of operation, and based on the type of analysis. First is based on the modes of chromatography. Generally we know that normal phase, in this normal phase mode, stationary phase is polar, that is silica gel, and mobile phase is non-polar. Now is revert phase mode, now it's invert to the normal phase mode, means stationary food is non-polar in revert phase and mobile phase is polar. It's a vice versa between normal phase and revert phase. Now on the basis of elution technique, it is a two type is a isocritic separation and gradient separation. Isocritic separation means same mobile phase combination is used throughout the process of separation, but in gradient separation, mobile phase combination of lower polarity or elution strength is used, followed by gradually increase the polarity or elution strength. Now based on the principle of separation, the adsorption chromatography, ion exchange chromatography, ion pair chromatography, size elution or gel permeation chromatography, now affinity chromatography and chiral phase chromatography. Now based on the scale of operation, we used analytical HPLC. Example, analysis of sample and very less quantity can be determined. So analytical HPLC we used for analysis of sample, and if the quantity of the compound is very less. And the preparative HPLC, example, individual fraction of sample are analyzed, more quantity of sample is required in this preparative HPLC. Now based on the type of analysis, now there is two type, qualitative analysis and quantitative analysis. In qualitative analysis, example, identification of compounds, detection of impurities, the presence of number of compound, we generally done in qualitative analysis. In quantitative analysis only we use quantify of sample. Okay, now move further, but as we know that ki high performance liquid chromatography method was first developed early in 1960 based on the principle of traditional chromatography technique, especially from column chromatography. Now the technique is based on the pumping of mobile phase through the packed column under the high pressure. Hence it is called a high pressure liquid chromatography. Now this method was first proposed by Kirkland and Huber. Then they proposed high pressure system capable of operating at pressure up to 1000 psi. So generally HPLC is thus basically a high improved form of column liquid chromatography. Instead of a solvent being allowed to drip through a column under gravity, it is forced through under high pressure of up to 400 atmosphere psi. Generally, the high pressure liquid chromatography is a method of separation in which stationary phase contained in one end of the column and other end of the column is attached to the source of pressure liquid elutant. It means mobile phase. The particle size is very smaller in comparison to classical column chromatography. Smaller the particle size, more will be the surface area and for better separation. Generally it is a type of simple chromatography, but high performance is a term which means is a effective method to separate